Hi, and welcome to 5.4. 5.4 is pretty much another word problems chapter. As we go through the textbook and we keep encountering these application chapters, what'll happen is they'll start taking away little pieces of the structure and expecting you guys to do more and more. So with this one, basically the major shift that they're expecting to do is what they're looking at is just looking at you to define your variables. So all that means is it's a pretty small step. All it means that before you start any problem, what you're going to have to do is you're going to have to basically tell yourself and your reader what you're talking about. Common variables are x and y. They're super common, which means they're comfortable, but they're not necessarily great for keeping track of what's actually going on. For example, if you're talking about cost, instead of x or y, c would be better. And then maybe give it some units, like dollars. If you're talking about number of people, again, instead of an x or a y, a p would be better. Just a word to the y's, a couple of variables to avoid. I can do them in red so that they think they're bad. Variables to avoid, the variable o. O is a very bad variable to choose. Y looks like 0. Sorry, Liz, like 0. Other bad variables, L looks like a 1. I seem to remember there being one other one that wasn't very good off the top of my head, but I can't quite remember what it is. Anyway, let's move on to an example. So, example 1, water freezes at 32 degrees Fahrenheit or 0 degrees Celsius. Water boils at 212 degrees Fahrenheit or 100 degrees Celsius. Graph the linear relationship between degrees Celsius and degrees Fahrenheit and find the formula that converts between Celsius and Fahrenheit. So this one's pretty good because the variables almost come up themselves, but we should still define them anyway. Let's go blue, I think. So temperature in Fahrenheit, we're going to call F. Lots of people write a little let up top. So let temperature in Fahrenheit equal F, and temperature in Celsius, maybe a little degree symbol there, equal C. So now we have our two variables. In just about all of these, you should really be thinking about two variables. You might need an intermediate variable, but ultimately, you're going to want it to go away. So what they're doing here is they really just want you to have a little sketch of a linear relationship. So we have water freezes at that point, 32 degrees Fahrenheit and 0 degrees Celsius, and water boils at 212 degrees Fahrenheit or 110 degrees Celsius. What I'm going to do is I'm going to make this axis, which is normally my x-axis, I'm going to make this my c-axis. And my up and down axis, which is normally my y-axis, I'm going to make my f-axis. So for the first point, which I've done in blue, 0 degrees, I'm going to go left and right 0, and then I'm going to go up 32. And I'm just going to do a bit of a sketch. So I'm just going to put a 32 there, and that's my point. For my next point, I'm going to go 100 over. So now I've got 100 over and up 212. So then I have my other point there. And that would be my relationship. And what I can do now is I can get out my ruler. I am 100% giving up on my ruler trick. I am actually going to physically place a ruler on my screen. And that is probably worse than my ruler trick. But there I have a graph between degrees Celsius and degrees Fahrenheit. Step 2, find the formula that converts between Celsius and Fahrenheit. So it is a linear relationship. Everything in this chapter you're going to pretend is a linear relationship. It tells you right at the top before your assigned practice problems that, in fact, pretend they're a linear relationship. Some of these aren't linear relationships, but could be modeled as linear relationships over small increments, and it's still a very valid tool to use and know, and we use it in science a lot. So we're down to word problems, and we're really thinking about critical thought. When we're thinking about critical thought, when we're talking about lines, the easiest one to use is y is equal to mx plus b, which is our slope-intercept form, where m is our slope and b is our y-intercept. General form with the ax plus bx is equal to c, or ax plus by is equal to c, isn't particularly useful in solving a lot of problems. It does come in handy at other times, but for this one, I think we're mostly going to use y is equal to mx plus b. So what we're looking for is either m and or b. In this case, if you're really with it and you're like, oh, I can see that this is my y-intercept already, I know that my y-intercept is going to be equal to 32. And then I know how to find my slope because I have 2 points, point number 1, point number 2. Now what we have to remember is that my f is my y-axis and my c is my x-axis. So my slope, I'm going to write the original equation down, y2 minus y1 over x2 minus x1 is now going to be equal, instead of y, and f2 minus f1 over c2 minus c1. And since I've already drawn these numbers up here, I've got my points. This is going to be f2, so 212, minus f1, which is 32, divided by my c2, which is 100, minus my c1, which is 0. I think if I plug this into a calculator, I get 180 over 5. If I reduce this fraction, I get 9 over 5. Notice how we might have to do some mental math here if we're asking for slopes in fractions. You can't just necessarily go ahead and plug everything into a calculator. Sorry, this was 180. I've made a mistake back here. 180 over 100. So you might have to have some pretty solid understanding in what's going, even though you might still be getting asked online multiple choice questions. So now I know what my answer is. I've got my y is equal to m, 9/5. And sorry, I don't need my y. I want my f. F is y. Y is equal to 9/5 c plus 32. And just for the record, this is a very, very real thing. This is the relationship between Celsius and Fahrenheit. This is the equation you need to use, which is interesting because in Canada, some of our older generations still pretty much exclusively understand what Celsius is, but myself and usually people younger really have an understanding of what C is. Okay, let's talk about what happens if you didn't necessarily think or didn't necessarily notice that this was a y-intercept. So if you don't, you should still be able to find the slope the exact same way. And so what you'll end up with, let's just do this one in a bit of a purple. We should still be able to get f is equal to 9/5 c plus this b. We want to know what b is. What we have, though, is we have our 2 points, point 1 and point 2, and they are both on this line. So they should both solve this equation. So we can choose one of them randomly. I'm going to choose point 1, which is 32 for f is equal to 9/5, and c is going to be 0. So this is kind of if I've just memorized and I'm plugging numbers back in, this process will work for me. 9/5 times 0 is 0. So I end up with b is equal to 32, and I end up right back there again. If, for example, maybe I chose the other point, so I should be able to do the same thing with point 2. For point 2, F is 212 and C is 110. So my 112 is equal to 9/5 times 100 plus B. And now in this case, what I'm going to have to do is I'm going to have to do a little bit of algebra. 112, and I might have to simplify this fraction. I get 900 over 5 plus B. Give me 1 second. I thought I had numbers typed in earlier, but I didn't have them all typed in. 900 divided by 5 is going to be 180. So I have a 112 is equal to 180 plus B. Subtract 180 from both sides. I think I've made a mistake somewhere, and this is the fun spot the mistake game. 212. There's my mistake right back here. My apologies. This is a 212. This is a 212. This is a 212. So 212 minus 180 is equal to 32. And so I knew I'd made a mistake because I wasn't getting the same answer that I got two other ways. And again, we're right back where we started. So moral of the story, in blue, if you notice some tricks that are going on, you can shortcut straight to the answer. But if you can't and you've got 2 points, you can find a slope. Then you can choose one of those 2 points, either method 1 or method 2, substitute a point in and then find out what your y-intercept is. I have at least one more example. I think I've got 2 for you. Okay. Oh, this is a good one too. The total cost of a TV is the sticker price plus 13% tax plus a recycling fee of 15%. So, this is kind of how it frequently works. If you go buy an electronic device, there's frequently tax on top of it, and then sometimes there's extra hidden fees. And in Canada, it's not the same all the way around the world. The price it says on the sticker isn't necessarily the price you pay. We usually add the tax on afterwards. So, A, express the total cost of a computer as a linear function of sticker price. So that just means make a linear function. So in your brain, you should be thinking y is equal to mx plus b. That's what we're trying to make. This one doesn't give us 2 points. It's a little bit different. So we need to think about how would we calculate the total cost of a TV? Well, we would take the sticker price, so S, let's call S sticker price. And I can do a little let up top, let S equal sticker price, and I can do T for total cost. And we're trying to find the relationship between that. Between those two variables, sticker price and total cost. So in order to calculate tax, and this is how you would calculate tax all the time, it would be a 13% on the sticker price. So if we want to calculate the total plus the 13, what you'd do is you'd take the sticker price and you'd multiply it by 1.13. This is the percent as a decimal. And then we add it to the 1. S times 1.13 is how we'd calculate a 13% tax. And then plus there's a recycling fee of $15, and that would be the total cost. So we just kind of have to logic our way through this one. T is equal to S, we usually write the number out in front, a 1.13 S plus 15, and that would be a final answer for A. If you don't like my 1.13, what you could write this out as, okay, my total cost would be the sticker price plus the taxes, which is 0.13, times the sticker price plus the recycling fee of $15. and this is going to end up the exact same answer, but in 2 steps. I will notice that my middle 2 terms are like terms. They both have the variable s, and out in front of here I have 1s, so 1s plus 0.3s is going to be t is equal to 1.13s plus 15. Again, 2 different ways. Notice how, same thing. We get to the same answer. Both are great answers for A. So let's look at B. What is the total cost of a computer that has a sticker price of $1,999.99? So this question is asking me what is the total price when my sticker price is $1,999.99. So what I can do is I can take this expression that I developed for part A, and then I can take these and substitute them in. So I don't know what t is, so I'm going to leave it as t, and I'm just going to switch colors so we can see I'm doing a different question. T, I don't know what it is, I'll leave it as t is equal to 1.13, my sticker price, 1999.99 plus 15. I can now, this is really nice, I can just take that right-hand side of my equation, I can plug it into a calculator, and I get $2,274.9887. And here I challenge you to think about what should we round to. We don't need to write down decimal after decimal after decimal. What we're doing is we're talking about money. So this here, this first 8, then the 0.98 would be the last cent. So we want to keep track of all of the pennies. So that, if we're dealing with numbers, would be if we're dealing with money, is where we'd round to. So $2,274.90. Since this 8, the second 8 is 5 or larger, we round up, 99. The total cost would be $2,274.99. Let's look at C. C starts out and looks very similar. If the total cost of a computer is $1,056, what was the sticker price? So this time they tell me the total cost is $1,056.00. I don't need to write down the 0 cents, so I'm not going to. And it's asking me what is the sticker price. So I just take that information straight from the question. I make my little shopping list. There we go. Once I have my little shopping list, I can go back up and I can look at this expression that I've developed. And T, I now know, is 1,056. And that is equal to 1.13. I don't know what S is, so I'll leave it as S, plus 15. So this one's a little bit different than last time. There are some numbers on the same side as my unknown. So I'm going to have to do some algebra to solve this. I'm going to have to try and isolate the unknown variable, which in this case is the s. The first thing I'm going to do is I'm going to move this 15 over. I'm going to get rid of it. I have to do the same thing to both sides. I'm going to subtract 15 from both sides, and I get 1,041 on the left-hand side and a 1.13 s on the right-hand side. To get rid of, or to get s all by itself, I'm going to get rid of the 1.13. It's 1.13 times s, so I'm going to divide both sides by 1.13. On the right-hand side, 1.13 divided by 1.13 is 1. 1 times s is s, so those are effectively gone. 1,041 divided by 1.13 is 921.238. That equals s. When we write a final answer, we usually write s is equal to, and again, we're going to round to that nearest cent, $921.24, since again, randomly we're at a second 8, which is 5 or larger. Example 3. It costs $295 for a group of 5 people and a bus to take a ferry, and $355 for a group of 7 to take the ferry and the bus. Find the cost equation. Okay, So what this is doing is, the first thing we're going to have to do is we're going to have to define our variables. So we're talking about two things. What are the two things we're talking about? If you don't know yet, try reading the whole question. How much will it cost for a group of people and the bus? C, if a bill was given for, oh, that's the cost again, and how many people? So it sounds like we're talking about cost and people. I would call cost C and people P, and that makes my life pretty easy. And again, we usually write that as a let. So it reads let cost equal C and let people equal P. A, find the cost equation. It looks like I have a cost with a number of people and another cost with a number of people. So it looks like, again, I have two sets of points. So I can find slope. I like to draw just a little grid and think about what would be happening. Typically, money will be on the y-axis, so I'm just going to put a dollar sign there, or maybe I'll put a C there. That's probably the best. And then this would be a P, and I can throw my dots on here just so I can keep track of them. And maybe actually I make this a bit bigger because it's being super useful for me. And the more useful it is, the bigger I'm tempted to make it. C and P. So I've got one down here with a 5 and 295, and then another dot up here with a 7 and a 355. And this sketch doesn't take long. It doesn't have to be incredibly precise, but it gives me a general idea of what's going on. So I can say my slope is rise over run, which is going to be a 355 minus 295 for my rise, 355 minus 295, divided by my run, which is going to be 7 minus 5, 7 minus 5, and I think I get 30. So my slope is going to be 30. So now I'm in this scenario again where I have part of a linear equation. C is equal to slope. And maybe I'll write it out properly first. Y is equal to mx plus b. And in my particular case, y is actually c. M is actually 30. X is actually p. And I don't know what this pesky b is again. So I'm going to have to go up and I'm going to have to take one of my points. I'm going to take this point, say. And I'm going to show you that, again, I'm going to do it both ways. You can do it just one way if you want, but I'm going to show you both ways. We're going to substitute those values into the expression. So my cost is $295, and that's equal to 30 times P is 5 plus B. I get a 295 is equal to 150 plus b, because I want to simplify first, and then I want to solve. I want to subtract 150 from both sides, or on the left-hand side, just to be tricky, I'm going to add a negative 150, which is the same thing. 150 minus 150 is b. Negative 150 plus 295 is going to be 145. So B is going to be 145. If you chose the other point, the pink point, I could substitute that into, let's see what happens, 355. This is also a great double check if you have extra time on a test or a quiz. If you get the same answer two different ways, chances are really high you're right. 30 times 7 plus B, I get a 355 is equal to a 30 times 7, I think is a 210 plus B. If I subtract 210 from both sides, I believe I get 145 is equal to B. Looks like B is going to be 145. I'll write my final answer in blue. I have an equation, y is equal to 30, C is equal to 30p plus 145. So if I want to break this down, 30 is the cost per person, and 145 is the fixed cost. We called it in other questions. In this particular context, it would be the cost of the bus. I would like you to take a minute and appreciate just how much work got written down to do that question. There is no way you're going to be able to sit down and do it without showing any work. The other reason you want to show your work is if you make a minor mistake, you can go back and see it. If you don't write any work down, you have no idea where you've made a mistake. And the third reason is 10 minutes from now, if you have to, say, for parts B or C, go back and look at it, you want to figure out what you did. And so you want that proof there for you. It should be this logical set of equations. This is like my intro sentence, and then we've got some middle paragraphs, and then I've got a conclusion. It's exactly like an essay or a well-written out logical argument that proves that this is the right answer. Let's look at B. How much will it cost for 12 people and the bus? So for B, I'm running out of space a little bit here. I might have to do B and C side by side. B gives us, sorry, I gotta scroll back up, 12 people. So P is equal to 12 and asks about the cost. So I can go ahead, I can substitute those into the equation. I'm starting to write small just so we fit. C is equal to 30 times 12 plus 145. This is one of those really nice ones where all I get to do is plug it into the calculator. C is equal to $505. Ah, love it when life is that simple. For C, it asks us how many people went on the bus if the cost is $745. I cheated and wrote down on a piece of paper, but we can scroll up and double check. The bill was given for $745, so I've got the cost. How many people were in the group? So again, I'm going to do exactly what I did in the previous one. I am going to substitute these values in. My cost is $745, and that is equal to 30. I don't know what P is, so I'll leave it as a P plus 145. Now, my variable is not all on its own, so I'm going to have to do some algebra. I'm going to subtract 145 from both sides. My right-hand side, it cancels. On my left-hand side, I'm left with a 600 is equal to 30p, and then I can divide both sides by 30, and p is equal to 20. 20 people went on that bus ride. And I think that brings us to the end of chapter 5.4.
Thank you for watching, and I just wanted to remind you guys a couple of keys for success. Number one, you got to do the practice questions. If the things I'm saying make sense, that's phenomenal, but you still have to practice and make some mistakes on your own. And that goes along with number two. If you get stuck, ask me questions, get in touch, write me an email, make an appointment, or leave a comment on the YouTube video. And step number three to success is look after yourself. Eat good food, get some exercise every day, and socialize as much as you can right now. I hope you guys are all doing well, and I will talk to you soon.